Hi students, today we are going to talk about real-time operating systems. Real-time operating systems are specialized operating systems which are used to manage the processes inside real-time systems. Just like normal operating systems, the real-time operating system provide an abstraction layer between application software programs and hardware. In other words, the real-time operating system hides the details of the hardware, just as a processor or set of processors, from the application software. We use real-time systems in order to increase the software productivity, means the speed with which we can produce the software, and in order to improve the overall performance of the real-time systems. As we know that in real-time system, the main thing is to do the job within the defined deadline. So if a programmer make a program which follows the deadline, but the operating system is spending too much time, so the overall goal cannot be achieved. That's why we use real-time operating systems in order to save this time and to provide good performance for the real-time systems. Let's compare real-time operating system with general operating system such as Windows and Linux. In Windows and Linux and other general operating systems, the tasks are scheduled on the basis of internal algorithms such as first come first serve, shortest job first, round robin, and so on. These systems do not care what is going on in their environment. However, real-time operating system is different from the general operating system because it schedules the task on the basis of external events which are signaled with the help of interrupts provided by the sensors to the computer. Second difference is that the real-time operating system has command interpreter just like general operating systems, where you can type commands. For example, the command prompt in Windows or shell in Linux family. But the command interpreters of real-time operating system is very simple and they do not normally include many utility programs. The goal of real-time system is usually to serve the system itself rather than human users, whereas the general operating systems are made to serve the human being. Real-time operating systems has deterministic timing behavior. It means that you can determine, you can calculate their timing behavior. In other words, you can determine that a particular job will be performed in this amount of time. This is because this real-time operating system is based on mathematical formulas which you can use to calculate the timing behavior. Secondly, it does not include random timing components. Random means one time they will take 2 seconds, for example. The other time they will take 3 seconds or 5 seconds. So random timing components are not included in real-time operating systems in order to avoid delay and missed deadline. Let's see the structure of real-time operating system. The real-time operating system consists of 4 components. These are executive, kernel, application program interfaces, and real-world interfaces. Kernel is the most important part of an operating system. Another definition of kernel is that it is the part of operating system which always resides in memory. Executive is the overall controller of all computer programs. It directly controls scheduling, mutual exclusion, data transfer, and synchronization activities. Basically, kernel provides all facilities to the executive, so you can consider executive as a boss. Just like in a company, there is chief executive. So executive behaves like a manager and kernel is the main executor. Application program interface is that part of operating system which interacts with application programs. Similarly, the real-world interface is that part of operating system which handles the hardware of the system. Let's see some of the basic services which are provided by a real-time operating systems. The first and foremost is the task management. Due to the task management, the software developers are allowed to write their program as a number of different tasks. So a software program can be divided into different tasks because at the hardware side we have multiple processors or cores available. So a programmer can divide its program into several different tasks or chunks which can then execute it concurrently in order to save the time. So the operating system provides this service to manage these tasks, and since the resources are limited, so the tasks are then scheduled so that they can use the resources efficiently and properly. The second service provided by in real-time operating system is InterTask Communication and Synchronization. By task communication, it means that one task can pass data or information to another task. While transferring this information, the operating system makes sure that this information does not lose and it reaches without any damage. It is maybe possible that task A want to send some data to task B, or task want to use the data of task B, but task B is not aware of this or maybe not working. So it is the responsibility of operating system to synchronize both tasks so that when the data of task B is needed, it can provide to the task A. In this way, the real-time operating system make it possible for the tasks so that they can coordinate and cooperate with each other. Another service provided by real-time operating system is the memory allocation. This memory is allocated to different tasks dynamically, means that when they are in execution, operating system allow tasks to borrow some part or chunk of memory for their use temporarily, and once the task finish, then the same memory is given to the other task. Besides these basic services, the real-time operating system also provides the service of device input-output supervision, means that input and output devices, just like sensors and actuators, are working correctly or not, whether they are on or off, and they are providing or using the data correctly. Similarly, another service provided by the real-time operating system is timer service in order to calculate the time, just like we calculate it with the help of watches and stopwatches. With the help of this service, we can check that the tasks are not delayed and they are not time out. Here are some of the examples of real-time operating system. Micrium is the name of the company. Micro C operating system 3, AVRX, QNX Neutrino. Linux has also developed its own real-time flavor, which is known as real-time Linux.